Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to explain to you how to explain your logistic regression model. So I'm going to show you how to explain your logistic regression model. So I'm going to show you for binary and for multi-classification. So how you look at a binary classification, logistic regression is quite a little bit different from multi-class classification. Multi-class classification makes the explanation a little bit more complicated, but it's very similar. So I'll start by showing you binary because it's very simple, very straightforward, and is easier to understand. And then I'll show you how to explain logistic regression results from a multi-classification perspective. So quickly, logistic regression uses the logit length function to bend the line of best fit in order to convert classification problem into regression problem. That's kind of how it works. And because of the logit function, coefficient of logistic regression shows us the logarithmic odds that a feature contributes to the target given its x values. So let me go ahead and print my x values here so you kind of see what I mean. So these are the x values for our data frame. This is the training. Of course, we also have the s-test data frame. So in the last video, I showed you how to build a logistic regression model. So I have a logistic regression model that's already been built, and this video is going to be focused on explaining it. So to get the coefficient of the logistic regression, you just do lr.coefficient. All right. And if we go back here and look at this real quick, LR is my logistic regression model. Okay, that's where I'm getting LR from. And if we look here in the logistic regression documentation, you can see that coefficient is one of the attributes that's available with this function. It also has a class attribute that shows you the list of class labels, and then it also shows you the intercept. You can think of the intercept as a bias added to the decision function. And then n enter is like number of iterations. So coef is just the coefficients of the features. All right. So these are the coefficients for my binary classification problem. And here, if I go ahead and do lr.classes, you can see that this is a binary classification problem, right? There's only two classes, 0 and 1. Okay, so this coefficient is the coefficient associated with this binary classification problem. Now let's look at the intercept. This is how you get the intercept. It's very similar. You do lr.intercept, and this is the intercept added to this binary classification problem. Now, what are the columns that we use? So if we go ahead here and do xtrain.columns, so these are the columns available to us, right? So each one of these coefficients corresponds to one column. And the thing is, like, when you're looking at this, it's kind of difficult to make decisions or to make conclusions about your model just looking at these raw numbers and looking at these raw columns. So that is why I'm going to take this and combine it with this to kind of create a pandas series. Now let's call it coefficient. Coef is equal to pd.series. So now that we have a pandas series that kind of shows the coefficient along with their corresponding columns, it kind of makes it easier to see the relationship that's going on here. Okay, now I'm gonna create a visualization to kind of visualize this right here. And after creating this visualization, then I'm gonna go back and explain what these numbers actually mean before we dive into multi-class classification. And I'm gonna show you the difference between explaining a multi-class classification and explaining a binary classification. So first, let's go ahead and start by creating a visualization. So assuming you already have matplotlib on your environment, you can go ahead and do this. You can do coefficient dot sort values dot plot dot bar age, and we don't need to specify a color. Sometimes I like to specify a color, but sometimes I don't. So let's go ahead and plot this. So right here we can, this is kind of like a plot of the coefficient and their corresponding column. So this is one way to visualize the results of your logistic regression model. All right, and in order for you to be able to do this plot and this bar dot age, you have to have matplotlib in your virtual environment. So make sure you have matplotlib in your environment. If not, you won't be able to do this. Now if we scroll back up a little bit, as you can see right here, these numbers are logarithmic odds, so log odds that a feature contributes to targets given its x values. So basically, let's take age for example. Okay, this right here belongs to age. Okay, this is the logarithmic odd that this feature contributes to our target given these x values right here. So that's kind of how you can look at this. But if you're just speaking to somebody in layman terms of logarithmic odd and everything in between, it may not make sense. And once we get to multi-class classification explanation, I'll go deeper into how to explain this in normal terminology. But I kind of wanted to give you a preview of how you would kind of like explain binary classification. So now that we are in multi-class classification, so in this multi-class logistic regression, I also called my model LR. So if you see me using LR again, don't get confused. All right, so for multi-class classification, if I do lr.cof, whoa, we have a whole lot of numbers, right? So when we did binary classification, we only had one number like this, but when we get the coefficient for multi-class classification, we have a lot of numbers, a lot of coefficients. Now to quickly understand this, we have to look at the class. So if we do lr.classes, you can see that in this multi-class classification, we have 7 classes. Okay, we have 3, 4, 5, 6, 7, 8, 9. So the way to look at this is that this first coefficient belongs to the 3 class, the number 3, and this first coefficient belongs to the number 4. This third coefficient belongs to the number 5 all the way to the last set of coefficients, which belong to the number 9. So that's how you would look at this for multi-class classification. So basically, this second data set is trying to predict the wine quality, and these are the columns that is being used for the prediction, or the features that is being used for prediction. So basically, looking at these features, looking at the classes and looking at the coefficients, right? What you can look at here is like this is, so this first one kind of belongs to the first, you can think of it as belonging to like to the first class. So because we have 7 different classes here, that's why we have like 7 sets of coefficients. But yeah, you can be like the log odd of fixed acidity belonging to class number 3. It's kind of 0.043. That's the log odd. Okay. And I know this kind of it's a little confusing, but I'm doing my best to kind of explain what these coefficients mean. But then what if you want to translate this log odds into regular terminology? Well, this blog post does a really good job of explaining it. So to convert this logarithmic odds back to normal numbers, you just use exponent function. Okay, and for negative coefficients, you just divide it by 1. For example, 1 divided by 0.15. All right, so let me go ahead and demonstrate this and kind of show you quickly how you will convert these logarithmic numbers back into normal numbers. But before I get to that, let me just show you the intercept. And of course, if we do LR.intercept, and what you notice right here is that we have multiple intercepts. So when we looked at the binary classification, we only had 1 intercept, and in this case we have 7 intercepts because we have 7 different classes. Basically, looking at all this information, like looking at the classes, looking at the columns, looking at the coefficient, and looking at the intercept, the way to kind of interpret this from beginning to end is like, so we have 7 classes. This is the log odd that the fixed acidity column belongs to the 3rd class. This is the log odd that the volatility acidity column belongs to the 3rd class. This is the log odd that the citric acid column that belongs to the 3rd class, stuff like that. And then this is the intercept for the 3rd class. This is the intercept for the 4th class, for class number 4, right? This is the intercept for class number 5. This is intercept for 6, and so forth and so on. So when you're looking at these numbers, that's kind of what they mean. So we are going to import numpy as np, and then we are going to say odd class 1, or just odd class 0, is equal to np.exponent, and then I'm going to do error.coefficient 0. So basically right here I'm just using the first one as an example, and right here I can copy this and put it here. And so I'm just working with this one right now, and then I can go ahead and copy this. Let's just call this 1 for clarification. All right, so basically now that I have converted these logarithmic numbers into actual numbers, I can say something like there's a 1.5% chance that this column belongs to the 3rd class. That's kind of how you will talk about this. That's kind of like the technical terminology that we use to explain this coefficient. So now how do you actually graph it, right? So if I do coefficient go off is equal to lr.go off. So in this situation, we have multiple coefficients, right? When we did the binary classification, we only had one set of coefficients like this, but now we have about 7 of them. So how do you graph it? Graphing it is also very similar. And here I'm going to define my columns. It's equal to x train.columns. And now just making sure I have matplotlib inline. And then I'm going to do coefficient is equal to pd.series. PD stands for pandas, by the way. Earlier I did import pandas as PD. So if you didn't know that, now you know. So now we are gonna do go off at position 0, okay? And then we are gonna do columns. And actually I'm just gonna do coefficient and run this. So now we have the coefficient associated with each class, but for the class that has a value of 3, if I do this again, lr.classes, okay, so this is for class value 3, and then I can do this again for, like, let's say let's do 1 here, and this is for class value 4. So that is how you'll be able to attach the corresponding coefficient to the columns. And remember, this is logarithmic odd. So instead, if you don't want to be working in logarithmic odd, if you want to be working with the actual numbers, like I showed you here, you will just let's say take this and then replace it with this and run this. So now you have the numbers associated with it. That's if that's what you wanted to do. But I just go ahead and leave it as it was before. Position 0. Now let's go ahead and actually plot it. So here I'm gonna do coefficient dot sort values dot plot dot bar h. So we just plotted our logarithmic odd of each class belonging, of each feature belonging to class number 3. And of course we can do something similar here. So for class number 4, we are looking at the logarithmic odd of each feature belonging to this class. And then of course we could change this and do it and use the real number version instead of the natural log version. Okay, so this is what it looks like, but then the problem with this is that it doesn't really give you negative values and positive values, and things like that. So I mean, this is mostly converting from logarithmic odd to regular numbers is good for, like, telling somebody, oh, there's a 1.6 times chance that volatile acidity makes an impact in grading a wine as third class. So, like, basically we are saying, like, what's the odd of these features and putting a wine and wine quality at 3, what's the odd of these features putting a wine quality at 4. And I know this kind of sometimes it's difficult to get all this technical jargon, but I think I've kind of explained it to the best of my abilities. If you have, like, any questions, just let me know in the comment section, or if you think I got something wrong in this video, please let me know and correct me in the comment section, because I'm still learning just like you. And I hope you like this video, and I hope this video provided you with value. You can get this notebook here at machinelearningeducation.com. This is a platform I created for giving you access to all my resources in one place. So if you go to machinelearningeducation.com/free, you get access to my free data science resources, and that includes this notebook. So I create a lot of YouTube videos and a lot of blog posts, and I just find it easier and more straightforward to take that notebook and all my videos, all my blog posts, and put them into one platform. And whenever you go here, you get access to this notebook and other notebooks. And you can also visit me online at evidencen.com. This is my primary website where I have my data science blogs. And as time goes by, I'm going to add more and more stuff to my data science blogs. So check me out online at evidencen.com. And if you are here, you can also click on free data science resources and be able to get to this page. That's it for this video. Thank you for watching. Let me know your comments in the comment section below or your questions. Give this video a thumbs up and subscribe. If you didn't like it but you made it this far in this video, give it a double thumbs down and still subscribe. I'll talk to you next time. Bye.